Right. So now we will move on to a very special segment. We have with us our summer intern here at On Semiconductor. Her name is Eleftheria Safarika. She is from Greece and has completed her first year studying electrical and electronics engineering at Imperial College London. She's a UK ESF scholar, and she's here to talk about her journey and motivations that led her to choose a career in electronics. So without any further ado, let's welcome Eleftheria. Hi, Eleftheria.
Hi, it's very nice to be here, and I'm very glad to be able to talk to this event and also to be a part of On Semiconductor.
We are so glad to have you. I'm so glad you could join. So let's start with you talking about your journey so far and what motivated you to pick up a course like electronics at the university.
Right. So before university, I studied in the IB. It wasn't until starting the IB that I decided I wanted to study electronics. Initially, I was leaning more towards a physics degree. However, after having a few practical experiences, both with physics and engineering, and as well as conducting my own personal research, I realized that a more applied path suited me better than a more theoretical approach to physics and mathematics. So the practical experiences that I had were, first of all, working on a school engineering project, building an electrical car, as well as studying an electronics course in a summer school, which were the hands-on experiences that turned me towards electronics and engineering and more practical degrees. So on the other hand, I explored a more theoretical approach to physics when I did a research program on particle physics on a research center in Greece. And after having both those two points of view towards physics and mathematics and science in general, I realized that I preferred practice over theory, and I wanted to see how the things that I learned would apply to the real world. And that's how I started leaning towards electrical engineering. And after conducting my own research on the modules and degrees that were available in universities and the specific topics taught in electrical engineering, my decision was really solidified, because electrical engineering is a really, really wide field that is applied in all aspects of everyday life, in industry, research, and it's literally everywhere. So that's one thing that really attracted me to the subjects. And I can find electrical engineering in so many aspects of daily life, from power electronics to communications and signals to artificial intelligence, semiconductor devices, control systems, everywhere. So I could see just countless possibilities from following a field such wide and so rapidly evolving as electrical engineering.
That's really interesting.
Yeah.
Thanks for sharing that, Eleftheria. So can you share with the girls what exactly you're doing at the university now?
Mm-hmm. Yeah, so currently at university, I am studying electrical and electronic engineering. In our first year of the course, we had some core modules, which were mathematics, analysis and design of circuits, as well as digital electronics and computer architecture, and also a programming course. There were in those modules, we were basically taught, apart from the necessary mathematics that is needed to tackle any kind of electrical system, we were also taught the more analog point of view towards electronics, which was analysis and design of circuits, where we did resonance and RLC circuits and generally analog electronics, as well as a more digital point of view towards electronics, which was digital electronics and computer architecture, which was basically logic gates, by learning about binary and how to make state machines or design a CPU, which was very interesting as well as CPU design. So we had those two kinds of analog and digital path, mathematics, which is necessary for everyone, as well as programming in C++, where we started from very basic things for anyone who even didn't have any experience in programming. And we even reached structures such as linked lists or binary trees, and we did projects on those and programming assignments. So it was, we were equipped with a lot of skills from all the kinds of fields that are necessary for electronics, maths and programming and all those kinds of things. And obviously we also had the more practical practical parts of the modules, which were the labs, which were necessary for both for analog electronics and for digital electronics. The labs were able to be done remotely this year as well, but also in person. For example, in the first term, I was in the labs every single time that we had a session, because it was just so much easier to work hands-on with all the equipment and build circuits on breadboards using resistors, transistors, diodes, things like that, and learning how to use an oscilloscope to see waves and actually hear even sound waves as well. And the other parts of the labs were included simulating circuits on simulating software such as LT-Spice, or building circuits using another software for digital electronics that was developed by the college. And those kinds of experiences were really, really helpful in seeing how the practice ties in with the theory that we would learn during the courses, because obviously the material, when we just learn it in theory, it's not as solidified in our minds as when we actually apply it and do the hands-on thing. So it definitely helped with understanding the theory much, much better. In general, also, I should mention that our department at Imperial offers two different streams for the same degree. It's the electrical and electronic degree, and there's also the electronic and information degree. So it's basically the classic electrical and electronic degree, and then there's also a stream that is more focused towards computing or digital electronics, and is more towards the digital part of things rather than the analog. But it's two different streams that largely overlap. So I'm currently doing electrical and electronic engineering, and I will continue doing that over the next years as well. But there's a lot of options in the next years of our degree to choose our own modules and build our degree the way that we want it, and so that we can take modules that are actually very interesting for each one of us individually.
So did you say that no prior knowledge of programming was required to get into the course? So do you have students who have different levels of abilities when it comes to programming?
Yes, definitely. There's a lot of people who have done a lot of programming on their own, or maybe they had experiences with robotics, but there's also a lot of people who were completely new to programming, and we would build, in our course, we built from the very basics. So we learned everything that was necessary. We are using C++. So even if people hadn't used the language before, they were able to learn everything that was needed and progress and have no issue with tackling all the projects that we had to do.
Perfect. This would be really useful for the girls.
Yeah.
Which subjects would you say would be important for them to definitely take to get into electronics, say at one of the top universities?
Oh, so in school, the topics in school.
Yeah.
Yes. So I did not do A levels, so it's my experience might be a bit different from theirs. But in the IB, I had my subjects were maths, physics, and chemistry high level. Chemistry wasn't necessary; it was just an option that I took for myself back then in the IB. But essentially, I would say that the top subjects that they should focus on are maths and physics. I would even say a bit more on maths, because maths, all the maths, half of the maths that we did in the first term in university, I had done before in the IB. So all the knowledge that I had from my school was able to help me get through the first term of university. Physics as well, especially the part relating to circuits, obviously, and electromagnetism and everything that is related to electrical engineering, but also the rest of the concepts in physics are just very, very general and important for an engineer to have. And those are definitely skills that, if as much as they can build upon, it's definitely something good.
That's really interesting. Thank you.
Yeah.
So could you share what kind of responsibilities do you have as an intern at On Semiconductor? What kind of things are you going to be involved in?
Right, yes. So at On Semiconductor, I am currently learning how to use CAD tools, which is computer-aided tools, for integrated circuit design. I'm right now working with the analog team. So what I'm doing right now is I'm learning how to use simulating software such as Cadence to design and simulate analog integrated circuits. I have completed right now my training more or less on understanding how to use the software and all the necessary tools. And I am right now designing operational amplifiers, which are basically the cornerstone of all analog electronics. So right now I'm working with a specification sheet, which gives me the necessary specifications for an op amp to design on my own. So I have to see how I'm going to achieve those specifications, how exactly I'm going to make the topology of the operational amplifier, what kind of MOSFETs I will be using, how I'm going to connect everything together. And basically, I'm doing right now the design work of building an operational amplifier. Essentially, this is what I'm more or less will be doing, designing, and maybe I will reach the stage of the layout of the circuit, which means basically how the blocks of an integrated circuit will be laid down on silicon, how they will be connected together, and hopefully I might be able to see the process of actually making the metal connections and laying the chip down on silicon and making actually the IC package. If this does not happen this year, maybe next summer, depends on how much time we're gonna have. But yeah, this is more or less what I will be doing.
That's perfect. Sounds fun.
It is.
So hope you enjoyed the internship at ON. And I think we have come towards the end of this session. So if you have any further questions or comments for Eleftheria or for me on my previous talk that I have just given, the floor is open now to you all to fire them away to us.
Yeah.
Thanks a lot.
Thanks,
you, Eleftheria, for joining again.
It was a pleasure. Thank you.
Bye.
Bye.